Welcome to the Bizarre, where we dive into the strangest, rarest, and most mysterious corners of our world. Earth is a planet of extremes: searing heat, bone-chilling cold, crushing depths, and air so thin it barely sustains life. And yet, against all odds, nature has created life forms that not only survive but thrive in these extreme environments. Welcome to Bizarre Adaptations: animals that live in extreme environments. Meet the tardigrade, also known as the water bear. This microscopic marvel can survive temperatures from nearly absolute zero to over 300 degrees Fahrenheit. They can endure extreme temperatures ranging from minus 458 degrees Fahrenheit to over 300 degrees Fahrenheit, withstand pressures 6 times greater than the deepest ocean trench, and even tolerate lethal levels of radiation. It shrugs off radiation, dehydration, and even the vacuum of space. Tardigrades are one of the few known organisms that can survive the vacuum of space. In 2007, scientists sent them on a mission to orbit Earth, where they were exposed to cosmic radiation, and many of them survived. How? By entering a state called cryptobiosis, essentially shutting down its metabolism until conditions improve. It's one of nature's true indestructibles. Tardigrades can lose almost all their water and shrivel up into a tiny, indestructible state called a ton. They can stay like this for decades and then revive when rehydrated. They've been around for over 500 million years. Fossil evidence suggests tardigrades have survived multiple mass extinctions, outliving the dinosaurs and enduring conditions that wiped out countless species. They can withstand DNA damage. Tardigrades produce a special protein called D-super, which protects their DNA from radiation and harmful environmental effects. Scientists are even studying D-super for potential applications in human medicine. They have a unique way of eating. Tardigrades use a needle-like mouthpart called a stylet to pierce plant cells, algae, or tiny microorganisms and suck out their nutrients. Could humans ever develop cryptobiosis, allowing us to survive extreme radiation or even space travel? In the blistering heat of the Sahara, where surface temperatures reach 158 degrees Fahrenheit, one tiny creature rules the dunes: the Sahara Silver Ant. They can tolerate body temperatures up to 128.5 degrees Fahrenheit, one of the highest known thermal tolerances in the animal kingdom. These insects have special heat-reflective hairs that keep them cool. Their triangular-shaped silver hairs reflect sunlight and reduce heat absorption, keeping their body temperature lower than the scorching sand. The Sahara Silver Ant holds the record for the fastest running speed relative to its body size, reaching nearly 1 meter per second, which is about 108 times its body length per second, which allows them to scavenge for food in mere minutes before the heat becomes fatal. These ants only leave their underground burrows for about 10 minutes a day, scavenging for food before the heat becomes unbearable. Instead of hunting, Sahara silver ants primarily scavenge the remains of heat-stricken creatures that couldn't survive the brutal desert temperatures. Could their heat-resistant adaptations inspire new materials for human survival suits? Imagine surviving in waters so cold that blood should freeze. The Antarctic Icefish has evolved to do just that without red blood cells. This adaptation helps them survive in frigid waters by preventing blood from becoming too thick. Instead, its blood contains antifreeze proteins that prevent ice crystals from forming. Since they lack hemoglobin, icefish absorb oxygen directly through their skin, allowing them to survive in oxygen-rich Antarctic waters. Their hearts are much larger than those of similar-sized fish, pumping more blood to compensate for the lack of oxygen-carrying hemoglobin. They're the only fish that can survive below freezing waters. Most fish would freeze solid in Antarctic waters, but icefish thrive at temperatures as low as 28.6 degrees Fahrenheit, that's minus 1.9 degrees Celsius. Could antifreeze proteins be used to prevent organ damage during cryogenic freezing? Atop the world's highest mountains, oxygen is scarce and temperatures are brutal. but the Himalayan jumping spider calls this home. Found at altitudes exceeding 22,000 feet, this tiny predator preys on insects blown in by the wind, making it one of the highest-dwelling animals on Earth. Since there are no plants or permanent food sources at such heights, this spider relies on insects blown up by the wind, patiently waiting for its next meal to arrive. Like other jumping spiders, this species doesn't build webs, but instead uses its strong legs and silk safety lines to leap multiple times its body length to catch prey. At such extreme altitudes, oxygen levels are about 1/3 of those at sea level, yet the Himalayan jumping spider has adapted to thrive in this environment. It can survive extreme cold thanks to natural antifreeze compounds in its body, preventing ice crystals from forming in its cells. Could understanding their oxygen efficiency help humans adapt to high altitudes or even Mars? At depths where sunlight never reaches, life takes on an alien form, the anglerfish. They live up to 6,600 feet or 2,000 meters below the surface, where the pressure is crushing and the temperature is near freezing. The tiny male anglerfish bites onto a female and fuses with her body, losing his eyes and internal organs over time, except for his testes to provide sperm whenever she needs. Female anglerfish have a bioluminescent lure on their forehead which glows due to symbiotic bacteria. This light attracts unsuspecting prey in the pitch-black depths of the ocean. They have huge extendable mouths and stomachs that allow them to swallow prey twice their size, perfect for a habitat where food is scarce. Because they live so deep in the ocean, anglerfish are almost never observed in their natural habitat, making them one of the most mysterious creatures of the deep. Could their bioluminescence be adapted for medical or military applications? In the deep ocean, near hydrothermal vents, water temperatures can exceed 750 degrees Fahrenheit. The Pompeii worm can survive temperatures up to 176 degrees Fahrenheit, making it one of the most heat-resistant animals on Earth. A layer of heat-resistant bacteria covers its back, acting like a biological heat shield against the boiling water near hydrothermal vents. While its tail end endures scorching temperatures, the worm keeps its head in cooler waters around 70 degrees Fahrenheit or 21 degrees Celsius, creating a bizarre temperature split within its body. The bacteria on its back produce mucus, which the worm consumes as food, creating a unique symbiotic relationship. Pompeii worms live at depths of over 8,000 feet or 2,500 meters near hydrothermal vents where few other creatures can survive. Could their heat-resistant bacteria be used to protect human skin from extreme heat? The wood frog does exactly that. The wood frog enters a frozen state during winter, with up to 65% of its body water turning to ice. Its heart and breathing completely stop, yet it revives in spring. Before freezing, the frog's liver floods its cells with glucose, preventing ice from damaging its organs. This sugar acts like a biological antifreeze. Wood frogs can remain in a frozen state for several months during winter, surviving temperatures as low as -8 degrees Fahrenheit or -22 degrees Celsius. It's the only amphibian known to live north of the Arctic Circle, enduring one of the coldest climates on Earth. When temperatures rise, the frog gradually thaws from the inside out, and within hours it hops away as if nothing happened. Could the ability to freeze and revive lead to advancements in cryogenic freezing for space travel or medical procedures? Could studying these animals help humans survive in extreme environments like space, deep sea, or extreme cold? What are the biggest challenges in applying these adaptations to human biology? Are there any ongoing experiments or scientific research trying to replicate these abilities in humans? Let us know in the comments. From the deepest oceans to the highest peaks, from searing deserts to the coldest tundras, life finds a way in the most bizarre and extreme ways. Nature's ingenuity knows no bounds. Which of these incredible adaptations amazed you the most? Let us know in the comments, and don't forget to subscribe to The Bizarre for more mind-blowing discoveries.